Heyo 20-1s. In this lesson, what we're going to look at is modeling applications of quadratic functions. These are definitely a little bit trickier, and you'll need to practice these probably a little bit more than you did just the other stuff we've been doing the last few lessons of completing the square and working on standard form. These can be tricky. Okay, let's start with a not so bad one first. So the flight of a Beebs CD is thrown upwards, can be modeled by this equation, where t is time in seconds and h at t is the height above ground in meters. Algebraically determine the maximum height of the CD. Okay, well, if we want the maximum height, what that really means I need the vertex. That's what that means. So let's do that. I'm going to change that just to a y for now. Maybe I'll just call it an h. Or maybe I just won't be lazy and call it h at t, right? Don't be lazy. You can be lazy, but I shouldn't be lazy. Okay, I want the vertex. So I'm going to complete the square. So parenthesis, parenthesis. I'm going to factor out that -2, which gives me t squared minus 3t. Remember now what we're going to do is we're going to divide the middle term in 2. So -3 divided by 2 is -1.5. And 1.5 squared is 2.25, I believe. 2.25. So that's what I'm going to balance with. So that squared is 2.25. Okay, but now to balance, it's really -2 times that, which is -4.5. So I'm going to balance by adding 4.5. And now we've got a perfect square trinomial in here. So this is t minus 1.5. How did I know that was 1.5? Well, again, it's that number that we got when we divided by 2, wasn't it? Plus 14.5. Okay, so what's the max height of the Beebs' CD? If anyone even buys CDs anymore, as it flies through the air, well, the vertex is 1.5, 14.5. So that's the max height that this CD reaches. And the 1.5 is the time it takes to reach the max height. Didn't ask for it, but it's a good thing to think about. Time to reach the max. There it is. So the Beebs CD likes to fly pretty darn high. Okay, that one wasn't bad because I gave you the function. What we're going to do is we're going to look at 2 more where we're not given the function, and this is where it gets more difficult. So a rectangular lot has a river on one side of it, and it's fenced off like you see below, using 60 meters of fencing. Determine the maximum area, max, as soon as I see that word max, vertex form of the enclosed space if we're not using fencing for the river. Okay, so first thing we're going to do here is, okay, I don't know what to do. Like, I'm stuck. But I use 60 meters of fencing. That sounds like my perimeter to me. Okay, well, my perimeter, I know how to find perimeter. In this case, its perimeter is length plus 2w, but they told me I use 60 meters of fencing. So there's my perimeter. Okay, but one equation, 2 unknowns, I can't do anything with that. Plus it says I want the max area. Okay, well, what about the area? Well, area, I know how to find the area of a rectangle. Most days, area is length times width. But we want max area. That doesn't help me at all. Well, actually it does. 2 equations, 2 unknowns. So here's what we're going to do. We want the max area. This is what we want. So what we're going to do is we're going to take our perimeter formula and we're going to substitute it in for area, into the area formula. So I am going to rearrange this perimeter formula just for L, because it's pretty easy to isolate for. So L is equal to 60 minus 2W. Now I'm going to sub this into the area formula. I'm going to sub this into length times width. Okay, what happens? Well, now what I have is area is equal to length times width. Area is equal to 60 minus 2W times W. Okay, I want max area, which means I want vertex form. So let's, at least, I don't know, I'm still stuck. Let's simplify this because it's looking ugly. So I'm going to distribute in that W. So I'm going to get negative 2W squared plus 60W. Oh, look at that. That's standard form. I don't want standard form. I want max area. Max means vertex. Vertex, we've got to complete the square. So let's complete that square. Let's factor out a negative 2. And now negative 30 divided by 2 is negative 15. Negative 15 squared sounds like 225 to me. And again, I'm going to balance. I didn't add in 225 really. I added in negative 2 times that, which is negative 450. So to balance negative 450, I'm going to add 450. And what do we have? Perfect square trinomial. So again, it's negative 15. I know it's negative 15 because that's what we got when we said negative 30 divided by 2 squared plus 450. Okay, did we answer the question? Well, our vertex is 15 and 450. So what are these values? That's your max volume. And what's this 15? Well, that's W. That's your width. That gives max volume. So we know the max volume is 450, whatever units, probably meters squared. And the width that would produce that would be 15 meters. So again, on these types of questions, what you're probably on the more difficult ones going to have to do is to make up two formulas, make a system, use substitution, and then complete the square. Okay, let's try one last one. The last one we're going to look at is a revenue question. What do we have? When 60 people attend a play, we're charged $18 per person. And then the theater company realizes if they drop the price by 50 cents, 10 more tickets will be purchased. Okay, so for every 50-cent drop in price, 10 more people will come. Makes sense. Drop the price, more people will buy. Increase the price, less people buy. Determine the cost per ticket so the theater will maximize its revenue. Maximize vertex form. Okay, well, first off, how the heck do we even come up with revenue? Well, revenue is simply this. Revenue is how many of something I sell, so number, times what I sell it for, dollar. So originally, the revenue of this company was 60 tickets times $18 a ticket, whatever that is, like 1,080 or something. So what is their new revenue formula? Well, we don't know quite yet because they're trying to figure out how many times they should drop the price. So let's set this up. Right now, they're selling 60 tickets for $18. So that's their original revenue. But now what they're going to do is they're going to drop the price by 50 cents. And every time they do, 10 more people will come. Okay, but we don't know how many times they're going to drop the price. That's what we're trying to figure out. So let's say they dropped it 2 times or 3 times or 4 times or 7 times or X times. So X let x be the number of times the price decreases. Let x be the number of times the price decreases. There it is. Okay, so there's our revenue function. But we want the max revenue. So guess what we're going to do? We're going to have to put this into standard form. So we're going to distribute everything out. And then what we'll do is complete the square. Now, on revenue questions, we get some numbers where we definitely need a calculator. So let's distribute this out. So 60 times 18 is 1080. 60 times a half is 30x. 10x times 18 is 180x. And 10 times negative a half is negative 5x squared. Good. Let's just keep simplifying this. I'm just going to rearrange negative 5x squared, simplify 210x plus 1080. Good. Now there's our standard form. Now let's complete the square. So remember, bracket, bracket. I should actually say parenthesis. Parenthesis is what that is. Factor out a negative 5. That's x squared. That sounds like 42, but I don't want to screw it up, so I am going to check. Yes, it is. Negative 42x. Like that. Okay, so now we need to complete the square. So 42 divided by 20. 42 divided by 2 is 21. Try that again. 21 squared is 441. But now we have to balance. So remember, this is the part that I see people make mistakes. It was this times this, what we really added in. So 5 times 441 is 2205, that negative. So we'll balance by adding 2205 over here. And now we can complete the square. So revenue is negative 5. X minus 42 divided by 2 is 21. Plus, I'm going to put that in my calculator just to be careful. I know I can do it, but don't feel like making a mistake. There we go. Okay, what's our vertex then? Well, our vertex is 21, 3285. But what does it mean, right? Well, the 3285 is our max revenue. 21 is not the ticket price. The 21 is the number of price changes. Okay, they're going to change the price 21 times. Okay, well, wait a minute. We're going to change the price 21 times. And how much were they changing the price by each time? 50 cents. So if we want to determine the new ticket cost here, our new ticket cost, or new ticket price, whatever you want to call it. Originally it was 18. They were dropping it 50 cents, and we're going to drop it 21 times. So our new ticket price is going to get a lot cheaper, isn't it? They're going to get those kids into the school theater. Our new ticket price is going to be $7.50. There it is. Okay, so again, for a revenue question, revenue is numbers times dollars, and then change your function based on what you're doing to the price. Okay, there it is, friends. See you next time.